Assalamualaikum and hi. I will explain the example for heat equation case B in this video. Given a steel rod 2 pi unit long, alright, 2 pi unit long means that L is equal to 2 pi, has an initial temperature of 5x degrees Celsius, which means that here initial temperature T equal to 0, Ux0 is equal to 5x. Both ends of the rod are insulated. Insulated means it is case B. If the temperature of the rod satisfies the heat equation, del U over del T equal to 6 del squared U over del S squared, find the temperature distribution UXT. This is the heat equation given. First step would be extract all the information. First, the heat equation, del U over del T equal to 6 del squared U over del S squared. Next, since it is case B, the first and the second condition is del U over del X 0T equal to 0 because it is insulated, no heat flow. Del U del X 2 pi T equal to 0. And the third condition, Ux0 equal to 5x. Let UXT equal to x of x times T. And therefore, del U del T is equal to s of x t prime t because we differentiate u with respect to t. Del squared u over del x squared equal to s double prime x t of t. Substitute in given PDE. X of x t prime t equal to here 6x double prime t of t. Rearrange. Make sure you bring the constant together with the function of t time. And both equation will be equal to negative lambda squared, which is a separation constant. After that, for negative lambda squared less than 0, x double prime x divided by x of x equal to negative lambda squared. Rearrange this equation and hence we will get this equation. Based on auxiliary equations, this equation will be m squared plus lambda squared equal to 0 and m is equal to plus minus lambda I. Therefore, x of x is equal to a1 cos lambda x plus a2 sin lambda x. And for the function of t prime t divided by 6t of t equal to negative lambda squared. Rearrange, it will be t prime t plus 6 lambda squared t of t equal to 0. Based on auxiliary equations, it will be m plus 6 lambda squared equal to 0 where m equal to negative 6 lambda squared and therefore t of t is equal to b exponent negative 6 lambda squared t. And hence we get uxt equal to in bracket a1 cos lambda x plus a2 sin lambda x multiply with b exponent negative 6 lambda squared t. Make sure you write s of x in bracket because uxt is a function of x times t of t. Next, apply the first condition, which is del u over del x 0t equal to 0, which means that x prime 0 t of t equal to 0 because here is the value of x. T of t does not equal to 0, therefore x prime 0 equal to 0. This is the function of x. Determine x prime x by differentiate x with respect to x. It will be negative a1 lambda sin lambda x plus a2 lambda cos lambda x. X prime 0 equal to 0 from here. Then substitute the value of 0 in x prime x. It will be negative a1 lambda sin 0 plus a2 lambda cos 0 equal to 0. And here a2 lambda equal to 0. a2 equal to 0 or lambda equal to 0. Since we have two values that we need to consider, first let's solve based on a2 equal to 0. For a2 equal to 0, x of x is equal to a1 cos lambda x. Apply the second condition, which is del u del x 2 pi t equal to 0, x prime 2 pi t of t equal to 0. T of t does not equal to 0, remember that. And therefore, x prime 2 pi equal to 0. This is the x of x for when a2 equal to 0, a1 cos lambda x. Differentiate this function with respect to x. Therefore, x prime x is equal to negative a1 lambda sine lambda x prime 2 pi equal to 0 from here. Okay. Negative a1 lambda sine 2 pi lambda equal to 0. a1 does not equal to 0 because if a1 equal to 0, there will be no solution. Therefore, lambda equal to 0 or sine 2 pi lambda equal to 0. Since we need to consider lambda equal to 0 again, we will calculate the solutions based on lambda equal to 0 after we complete for a2 equal to 0. Now, sine 2 pi lambda equal to 0, which means that sine 2 pi lambda is equal to sine n pi because sine n pi is equal to 0. 2 pi lambda is equal to n pi. So, lambda is equal to n pi divided by 2 pi. Simplify and lambda is equal to n over 2 for n equal to 1, 2, 3 until infinite. We can conclude that x of n is equal to a1n cos nx divided by 2. T of nt is equal to bn exponent negative 6 in bracket for the lambda, which is n divided by 2 power of 2 t for n equal to 1, 2, 3 until infinite. Since this is repetitively for every n, starting from n equal to 1, 2, 3 until infinite, that's why here it needs to be written like this, a1n, and also here bn. Thus, unxt is equal to an cos nx divided by 2 exponent negative 3 n squared t divided by 2. This one has been simplified because 6 times 1 over 4 would be 3 over 2. Where an is equal to a1n times bn. Okay, we change it to capital letter to make it much simpler. For n equal to 1, 2, 3 until infinite. After that, we solve for when lambda equal to 0. For lambda equal to 0, negative lambda squared will be equal to 0. Therefore, we need to solve it from the start again. Okay, so x double prime x divided by x of x equal to 0. Therefore, x double prime x equal to 0. Based on auxiliary equations, m squared equal to 0, where m is equal to 0 then. Therefore, x of x equal to c1 plus c2x. T prime t divided by 6t of t equal to 0, which means that t prime t equal to 0. Based on auxiliary equation, we have m equal to 0. And t of t will be c3 exponent 0. Exponent 0 is equal to 1. Therefore, t of t is equal to c3 only. Thus, uxt is equal to c1 plus c2x in bracket times c3. Remember, it should be written in bracket because this is a function of x of x times t of t. Apply the first condition, which is del u del x 0t equal to 0, x prime 0t of t equal to 0. Since t of t does not equal to 0, therefore x prime 0 equal to 0. This is the function for x. Differentiate x with respect to x, it will be x prime x equal to c2. X prime 0 equal to 0. Hence, c2 equal to 0. Therefore, x of x is equal to c1 only because c2 is equal to 0. After that, apply the second condition, which is del u del x 2 pi t equal to 0. X prime 2 pi t of t equal to 0. T of t does not equal to 0, which means that x prime 2 pi equal to 0. X of x is equal to c1. Differentiate x with respect to x, it will be 0 because differentiate constant. And hence x prime 2 pi equal to 0 from here. 0, here 0 is equal to 0. That's why x of x will be c1 only. Thus, we can conclude that uxt is equal to c1 times c3, which is equal to c4, where c4 is equal to c1 times c3. Hence, u and xt can be written as a0 plus an cos nx divided by 2 exponent negative 3 n squared t divided by 2, where a0 here is equal to c4 earlier, for n equal to 1, 2, 3. U and xt is a combination of the solutions for when lambda equal to 0 plus this is for when C2 equal to 0. Using superposition principle, U and XT can be written as U x T A naught plus summation n from 1 to infinity A of n cos nx divided by 2 exponent negative 3 n squared t divided by 2. Where there is a change here. Instead of writing for n equal to 1 to 3 until infinity, it will be summation n from 1 until infinity in front of the terms that have n. Finally, apply the third condition, u as 0 equal to 5x, which means that a naught plus summation n from 1 to infinity an cos nx over 2 exponent 0 equal to 5x. Exponent 0 is equal to 1, therefore we will get this equation, which is a Fourier cosine series. This is the basic Fourier cosine series, which is fs equal to a naught divided by 2 plus summation n from 1 to infinity a of n cos n pi x divided by L. Capital letter A naught here is equal to small letter a naught divided by 2. Both are in the same positions. Therefore, 2a naught, capital letter A naught is equal to a naught, where we can use the formula for a naught to calculate the value of capital letter A naught. 2a naught is equal to 2 divided by L, which is 2 pi. Integrate from 0 to L, 2 pi. The function fx, 5x with respect to x. Integrate 5x is 5x squared divided by 2. Substitute the upper boundary minus the lower boundary. We get these values. And remember, this is still 2a naught is equal to 10 pi. And therefore, a naught is equal to 5 pi. After that, calculate an, which is 2 divided by L, 2 divided by 2 pi, integrate 0 to 2 pi, 5x cos nx divided by 2 with respect to x. Use the tabular integration method here, where u is equal to fx, differentiate u until you get 0. Differentiate 5x is 5, differentiate 5 is 0. And for dv, integrate cos nx divided by 2 is 2 over n sin nx divided by 2. And integrate this term is negative 4 divided by n squared cos nx divided by 2. Remember to add the diagonal lines here. Therefore, an is equal to 1 over pi times 5x times positive times 2 over n sin nx divided by 2 is 10x divided by n sin nx divided by 2, plus, because 5 times negative 4 over n squared cos nx divided by 2 is positive 20 over n squared cos nx divided by 2. Substitute the value from 0 to 2 pi. Remember, upper boundary minus the lower boundary. It will be like this. And sin n pi is equal to 0. Therefore, an is equal to 20 divided by pi n squared, open the bracket, negative 1 power of n minus 1. Hence, u as t is equal to a naught, which is 5 pi, plus summation n from 1 to infinity. This is the value of an that we had obtained earlier. Cos nx divided by 2 exponent negative 3 n squared t divided by 2. Alright, this we conclude the step-by-step explanation for heat equation case B. Thank you for your full attention. Assalamualaikum.